Here we discuss fractional knapsack problem. Here we have taken an item I1, I2, I3 and I4. You can see some part of the items are taken as a complete like I1 and I2, and I3 has taken as a fraction parts, and I4 is not taken at all. So that's the name suggests fractional knapsack problem. And you can see the cost or profit has been taken according to this. Since 1 and 2 item had taken completely, their cost has been or profit value has been taken as whole or complete manner, and I3 part has been taken as fraction, so that's why the $3 or profit value has been as a fraction part. I4 is not taken at all, and you can see there are no profit value are associated with this. Going for the introduction part, you can see the knapsack having a maximum capacity of WK we can assign that is greater than 0 value. And next we can go for the number of different items having profit value having V1, V2 and Vn. The profit individual in items profit value, and then the different item having different weight according to W1, W2 up to Wn. So a different item having different kind of weights. And as you can see, the name as suggests fractional knapsack problem, item can be taken as complete as well as in fraction manner. So, and obviously it is a greedy approach. Besides the binary knapsack, which is an uh, dynamic programming, it's opted a greedy approach, means every time it opted for the best solution, optimum solution. So the condition we have to check here for the fraction knapsack, will every time we looking for highest value or highest profit first. Okay, next obviously we'll going for the lightest weight first. Okay, because it will enhance, it will take the more item we can take according to this. And according to the first and second point, we will calculate the pi matrix, that is the ratio between vi and wi. So it, and sort this pi in descending order, then we'll choose the highest pi, means we'll choose the, in this way we'll choose the highest profit as well as the lightest weight item will be chosen first. Okay, so it will maximize my profit as well as it will try to increase the number of items in our knapsack. Okay, so both way it will be effective. So we maximum the profit having these constants. Obviously the constants are the summation of wi should be less than equal to wk, means the individual item weight should be less than the knapsack capacity. You can't take more the knapsack capacity value here. So you could go going for the problem discussing, and you can take the 1 2 3 4 5 items as there. The individual weight have been given 5 10 20 30 40. Individual profit have been given 30 20 100 90 and 160. So we will calculate the p matrix, or that has been v by w. So you can check the p matrix profit per weight, that is according to the item it's coming as 6 2 5 3 and 4. So as well as our problem suggest, we'll go for the descending order sorting. So here we will perform the descending order sorting, and you can check the item weight and the profit we are just arranging little bit. Okay, so according to this, the item having maximum p value, I1 item has come first, then come the I3 item which p value has 5, then coming the I5 item which p value having 4, then coming I4 item which p value having 3, then coming I2 item which is the least one, the p value having 2. Okay, so this is the actual setup of our problem. Now go for the solution. Going on the continuation, so you can just repeat the same matrix here, nothing more than that. Now we have to go for the selected item and total profit. Okay, so you can check, and as well as the remaining knapsack capacity. So obviously when we try to put item, the knapsack capacity will be decreased. Okay, so we'll mention the capacity 60, means we can't take more than 60 weight here. Okay, you have mentioned also the total, means the total profit value. So first of all we'll choose I1. Okay, check the I1 item has been taken which profit giving 30, and you can check the capacity also changed to 60 to 55, because the profit value has been 30 and the capacity have been 5, so the 5 weight value have been will be decreased. It will be capacity will be 55. Okay, next we will choose I3. I3 item having the profit value 100, we can check the 100 have been profit value added, and since its weight is 20, so 20 capacity have been decreased, so 55 to 35 have been the result. Okay, now the actual problem comes. According to this, next I5 will be chosen. Okay, now the check. Now I5, when I5 will be chosen, you can check there are 40 weight, but there are, you can't take 40 weight because in the maximum capacity in the previous example, we can check in this example there are 35 weight are remaining. Okay, so in this case we can take a part of the I5 item. Okay, so the part of, you can, I'm repeating the portions, you can check the part of I5 will be taken, you can check the capacity will be remaining as 0. As you can see that weight per profit value is 4, so in, since we taking only the 35 unit of weight, per unit profit value is 4, so the profit value will be 4 into 35, and you can check the capacity comes to 0 here. Okay, so actually we'll calculate the actual profit, so the actual profit comes as 270. Okay, in this fraction knapsack method. Okay, so here our problem has been completed. Thank you for watching the video.